Imagine traveling faster than a commercial jet, all while zipping through sleek tubes on the ground. On Iron Innovating, we're decoding how engineers worldwide are reimagining movement itself, using Hyperloop technology to rewrite the playbook for planet-sized problems like congestion and carbon emissions. Buckle up, this is engineering with no speed limits. Picture a world where the distances between cities blur, where travel at the speed of flight occurs at ground level, and where engineering ingenuity rewrites the rhythms of civilization. Welcome to the dawn of Hyperloop transportation. Once dismissed as science fiction, the concept of shooting passenger pods through near-vacuum tubes has become a crucible for radical ideas, uniting visionary engineers in a quest to solve age-old global challenges of mobility, sustainability, and economic disparity. Deep beneath bustling metropolises and across sun-baked deserts, Hyperloop's essence lies in its quest to erase both boundaries and barriers. By using magnetic levitation, maglev, these pods float frictionless, slashing energy consumption to levels never seen in traditional high-speed rail or air travel. What if your daily commute from Los Angeles to San Francisco was condensed to 35 minutes? Engineering teams at Virgin Hyperloop have already performed successful human trials, transforming decades-old blueprints into exhilarating real-world test runs that hint at a future within reach. Some still wonder, is this technology truly sustainable? In Pune, India, engineers are harnessing solar panels to power every stage of the Hyperloop system. Their simulations show energy-positive transit, meaning the system could generate more power than it consumes. The logistical nightmares of overpopulated megacities confront us as urgent puzzles. Congestion and pollution choke urban life. Yet with Hyperloop's sealed tubes, not only is land footprint minimized by elevated tracks and subterranean alignments, but emissions and noise vanish, ushering in silent corridors of progress. It's easy to overlook perhaps Hyperloop's most powerful impact: social transformation. By collapsing regional divides, entire labor markets suddenly become accessible. Imagine rural innovators seamlessly plugging into financial capitals each morning without uprooting their communities. But speed brings its own engineering gauntlet. The pods hurtle through tubes at over 1,000 kilometers per hour, demanding materials lighter yet stronger than anything used in aerospace today. Carbon fiber composites interlaced with nanomaterials, some newly invented for this purpose, provide both resilience and safety under immense stress. In Nevada's desert, during the early test campaigns, an unexpected phenomenon was observed. Magnetic fields interacting with desert dust created microbursts of static electricity. Engineers now deploy real-time electromagnetic dampeners, advanced beyond those on any aircraft, turning nature's mischief into new protective protocols for passenger safety. The cost conundrum looms over all. How do you build a new global network affordably? Instead of bespoke construction, engineers in Eastern Europe are perfecting modular tube segments manufactured with robotic precision and delivered like giant Lego blocks to be rapidly assembled on site. Consider cargo. Over 70% of goods in Africa are delayed due to poor infrastructure. Now imagine agricultural produce rocketing from farms to ports in mere hours via temperature-controlled Hyperloop containers, reversing food waste trends overnight and unlocking billions for local economies. Hyperloop isn't just racing towards speed, it's redefining accessibility for people with disabilities. Engineers have eliminated steps entirely. Climate control is constant. Acceleration is so gradual that even the frailest passengers feel only gentle movement. A spacecraft-like glide designed for true inclusivity. One staggering revelation: the vacuum environment inside the tubes mimics conditions found 60 kilometers above Earth's surface. This allows researchers to run atmospheric experiments alongside transport operations. Each pod journey doubles as a miniature scientific mission, gathering data valuable for climate science and aerospace engineering alike. Rival teams from Seoul to Abu Dhabi are solving cultural and regulatory puzzles unique to their regions. In Korea, engineers engineered seismic shock absorbers capable of withstanding earthquakes above magnitude 8. A world first for mass transit systems built underground and underwater. Critically, public trust hangs in the balance. To win hearts as well as minds, some Hyperloop firms now open their real-time operational data streams to universities and watchdog groups worldwide, a transparency unheard of in transport history, inviting scrutiny while accelerating innovation through collective intelligence. If you enjoyed today's dose of engineering, hit like and subscribe to stay inspired with Iron Innovating.